All right, so here we are. We're talking about matter. For this slide of practice, we're talking about our 4 types of matter: our elements, our compounds, our homogeneous mixtures, and our heterogeneous mixtures. Remember, our mixtures are physically blended. They're not chemically bonded, but our compounds are elements that are chemically bonded, and our elements are building blocks of matter. So for things that are physically blended, our mixtures, we are able to separate them by physical means, but our elements and our compounds, we can't separate by physical means. We would need chemical means. And in this unit, we're only talking about the physical separations of mixtures. So let's start with our water. Our water is going to be a compound, and that is because it is 2 hydrogens bonded to an oxygen. That is 1 molecule of water. Our salt water, however, is going to be a homogeneous mixture. And that is because the salt is not chemically bonding with the water. Now, how do we separate this? What if you leave a glass of salt water on your nightstand for 6 weeks? You can wait for that water to evaporate, and the salt will be left behind. Now, a poorly blended milkshake. This is definitely a mixture. We know that because we're not chemically bonding our milk, our ice cream, and our Oreos, maybe. But because it's poorly blended, we know that there's probably layers to this, which means it's not evenly distributed throughout, and this is going to be a heterogeneous mixture. How could we separate this? You could just sort of scoop out the Oreo layer, scoop out the ice cream layer, maybe pour off the milk. When you carefully pour a liquid off of the rest of your mixture or whatever you're looking at, in science class we call that decanting. You can decant the milk off of the rest of the milkshake. Solid steel, this is a tricky one. Steel is not an element. It is composed of iron and carbon. What's even trickier is that it's not a compound. That iron and that carbon isn't chemically bonded. Instead, what's happening is you heat up the carbon and the iron so much that it is molten, or at least the iron, the carbon might stay solid, to this molten liquid, and then you combine your elements. So this is really a homogeneous mixture. Because you can't pick out in your steel rebar where your carbon and where your iron is. How would we separate this? I'm not totally sure. You probably have to heat up your steel to very, very high temperatures again. When we have a mixture that contains a metal, like how steel contains iron, we call this an alloy. Gold, we can see it on the periodic table, so this is a pure element. But 14-karat gold, the carat system for gold tells us about purity. 14-karat gold is not pure gold. Gold is a metal, so this is going to be another homogeneous mixture. Specifically, an alloy. So that's choosing these categories, these 4 options: element, compound, homogeneous, or heterogeneous mixture. Now let's go to the next thing. So now let's classify each of these things as a physical or a chemical property. Remember, a physical property is something that you can observe or measure without changing the actual substance of the matter that you're looking at. A chemical property is the ability of that substance to undergo a chemical change, meaning that substance is changing. Old bonds are breaking and new bonds are forming. So observing that something is a blue color, that's going to be a physical property. Density, we can observe without changing what we have. That's also a physical property. Flammability. Now, combustion, setting things on fire, is typically a chemical reaction, which means the ability of something to combust, the ability of something to burn, is going to be a chemical property. Reacts with acid to form hydrogen gas. We know the formation of a gas indicates a chemical change. So if this substance can react with acid to bring about a chemical change, this is a chemical property. Sour taste. This is a tricky one. Now you could observe the sour taste of something, perhaps by sight. Maybe you can look at a Sour Patch Kid and you know that it's sour. So in one sense, you might be able to consider this a physical property. However, when you actually taste something, there are chemical reactions that are happening on your tongue and on your taste buds. So the ability of something to taste sour is its ability to interact chemically with your taste buds, which would make this, I would lean more towards a chemical property, but I could see the argument for physical. Melting point, state of matter changes are physical changes, so this is a physical property. Hardness, you can observe without changing what you have. You can see how hard a diamond is without changing it away from diamond, so that's a physical property. Luster, very similar. That's how shiny something is. You can see how shiny a copper wire is without changing that it's copper. Odor, for the same reasoning as sour taste. You could just observe that something smells bad, maybe even perhaps by sight or experience. However, your nose requires a chemical reaction to experience that odor. So that's going to be, I would lean more towards chemical for that. But I could still see the argument for both. Those are a little tricky.